Time-appropriate greetings, everyone, and welcome back. We're going to learn today about some of Excel's built-in functions that are going to make our lives easier when making computations. For example, let's consider this class of 25 students and their grades. Let's compute the sum, count, average, minimum, maximum, and the number of fails for this class. To find the sum, we could just start by typing equals, start a calculation, and then clicking the cell references and adding them up. I'm not going to finish this calculation because it's tedious, it's annoying, and it's also error-prone. Instead of clicking each individual cell over a large array of cells that we want to do a computation, we can use Excel's built-in functions to reduce error and reduce time. Excel has a function called sum for adding up. We still have the equal sign, but now we write the word sum. We put a left parenthesis, and it prompts us in bold blue for a number. What this is asking us to do then is to click and drag across this whole array of cells. Close this function with a right parenthesis, hit enter, and we have a sum. The sum of these 25 student grades is 1,817. The anatomy of a function is the name, usually telling you what it does, and some arguments. In this case, there's one argument, an array of numbers. Excel also has a counting function. We push equals to start a computation. We type the word count, left parenthesis, select our range, right parenthesis, hit enter. There are 25 students. Of course, we knew that, but Excel can also calculate these. If there were 3,000 students, we wouldn't want to have to do that by hand. For the average, let's hit equals and just start typing the word average. Even if you didn't know what the name of the function was, notice that Excel will drop down a menu with some suggestions. To choose the selection, you can just click the function name. It automatically completes it and puts a left parenthesis for you, indicating that it's ready to start. Instead of clicking it, you can also hit Tab. Once it's ready to start, we select the range of things we want. I'm also going to say here that if there are no errors in your calculation and you hit enter without putting that last parenthesis, Excel will fix it for you. Risky, but often works. It's better practice to just put the right parenthesis there when you know it needs to be. Excel has a minimum function, min. I'll hit tab, select the cells, enter. So the lowest grade was 26. And the maximum grade is computed using the max function. So the sum of the grades is 1,817. There are 25 grades. The average is 72.68. The lowest grade was 26 and the highest 98. Now let's calculate how many students in this class failed. That is, how many students in this class got less than a 50. Count isn't going to cut it anymore. But if we start typing count, which is what we want to do, we notice that there's a function here called COUNTIF. That sounds reasonable. COUNTIF is our first function that takes two arguments. It takes a range. Those are the cells that you want to count in, so it's our grades. And to get to the next argument, I click comma, and now it's asking for a criteria. I want to know, are these grades less than 50? As promising as this looks, it's not going to work, unfortunately. I hit enter, and I get a syntax error. There's a problem with this formula. This is a peculiarity with Excel, which requires that the conditions need quotes around them. Conditions need quotes around them when you're checking it for an array of cells. I hit enter, and there are 3 failing grades, 26, 42, and 32. There are 6 comparison operators for use in these criteria. Of course, there's less than, the less than symbol. There's also less than or equal to, which is just a less than sign with an equal sign after it. Naturally, there's a greater than, and a greater than or equal to. You can also check for equality with the equals. Notice that this equal sign is going to appear in the middle of a formula, not at the beginning of a cell, so Excel will know it's being used for equality rather than to start a calculation. And last but not least, not equal to. It's a little strange. It's kind of like a less than and a greater than glued together. Using these 6 operators, you can concoct many conditions for a COUNTIF. The last common function that I'm going to introduce is the if function. And to demonstrate the if function, I'm going to, for each of these grades, decide if it's a pass or a fail. If it's greater than or equal to 50, so I'm going to be using this symbol, then I'm going to assign that student a pass. If the grade is less than 50, I'm going to assign it a fail. To start this, I'm just going to choose a block here, and I'm going to start typing if. Notice that if has 3 arguments. COUNTIF had 2, the rest had 1. If is going to have a logical test or a decision. In this case, I want to test if the grade is at least 50. Then if that decision is true, it's going to do one thing. And if the decision is false, it's going to do another thing. Our logical test is going to be taking the grade and checking if it's at least greater than or equal to 50. Notice that I didn't put quotes around this comparison because instead of a whole range of comparisons, I'm only comparing one cell to one number. If this student has a grade at least 50, I'm going to print the word pass. I have to put the word pass in quotes to tell Excel that I want to put this word in the cell if it's greater than or equal to 50. I don't want to do a calculation. I want the value to be this word pass. I push comma again, and now it's highlighting value if false. Well, if this is false, if the student's grade is not at least 50, that means it's less than 50, which means the student has failed, unfortunately. I hit enter, and the cell becomes fail, and that's because 26 did not pass the test. I checked, is 26 greater than or equal to 50? That's false, so it went with the value if false. I can now move this to the rest of the grades over 5, so there's the 4 extra passes there. And I can drag this down 5. And now it's very easy to see that the 3 fails were the 42, the 32, and the 26. Let's now add a little bit to this. Instead of just pass and fail, I want to distinguish the students that pass with a 90 or above with an A+. So instead of a 50, I want to check if the student gets a 90. And if they do, instead of a pass, I want them to receive an A+. Now if they have less than a 90, right now they'll fail. But instead of failing, I then need to make a second decision. If a student has less than a 90, they can still pass if their grade is at least 50. So if they have a grade less than 90, I need to make a second decision as to whether they pass or fail. A second decision is a second if statement. It seems a little complicated at first, but the value if false is going to be another if statement. First, I'm going to check if the grade is greater than or equal to 90. If that's true, I'm going to print an A+. If that's false, I'm going to do another decision. The decision is going to be, I'm going to take the grade again. Now I'm going to check to see if it's at least 50. If the grade is at least 50, now notice this is the value if true in this if statement. If the grade is at least 50, I'm going to print pass, comma, fail. If the grade is not greater than or equal to 50, they will fail. Notice that this decision is only going to be forced if the student has a grade less than 90. Because if the student has a grade over 90, they're just going to get the A+. It will never make it to this if statement in the false part. Then, if it's less than 90, you then check if it's greater than or equal to 50. If that's true, I go to value if true for this if statement. And they get a pass, and they fail if not. A very common error is parentheses. Notice that the parentheses here are red to indicate that they match, and these are black to indicate that they match. Double check to make sure the parentheses are correct before you hit enter, or Excel can throw some crazy errors at you. I hit enter, and this student has failed. Of course they have, since their grade is still less than 50. Let me pull this formula over, and notice we have 2 A+, the 98 and the 91. Pull it down, and now we have 4 A+, the 90, the 93, the 98, and the 91. When an if statement has another if statement as its false value, that's called a nested if statement. You can think of them as Russian dolls nested inside of each other. Excel can do up to 64 of these before it starts to break. However, I would never ask you to do 64 of them because I would break before then. The functions sum, count, average, min, max, count if, and if statements are fundamental in the design of spreadsheets and will be used extensively and frequently throughout this course and throughout all spreadsheet applications.